This is the Building Automation Monthly Podcast with Phil Zito, episode 156. Hey folks, Phil Zito here, and welcome to episode 156. And in this episode, we are going to be starting a series on the ins and outs of building automation systems. So we're going to be taking a break from our normal 4-topic rotation to discuss something I've been getting asked quite a bit lately. So over the next 4 episodes, here's what's going to happen. We're going to go and we're going to review the parts and pieces of controls. Now, to make these episodes a little bit unique, what I'll be doing in conjunction with these episodes is recording a video episode that will be going on YouTube, and you'll be able to access it there. This week's episode's a little late. We had some computer issues last week, kind of messed everything up, so we're running a couple days late. But normally what will happen is these episodes will roll out on Mondays and the videos will roll out on Wednesdays. You can expect this video to roll out on Friday. So today's episode, we're going to be starting with inputs and outputs. Now, I know some of you are like, man, this is super basic, like inputs and outputs. Yet, if we think about most of the project issues we have, they are stuff not properly terminated, inputs improperly set up, jumper settings not properly selected, all that kind of jazz. Everything in that point-to-point checkout realm, and that's where stuff just kind of goes funky. So I really encourage you to listen through this episode. You never know what you're going to learn, and I would tell you that this will give you a way to look at inputs and outputs and communicate them to your technicians, as well as just to better understand them yourselves. So before we go there, this episode is sponsored by our course, Building Automation Systems Fundamentals. If you're looking for a course that will give you a technical introduction to controls, then Building Automation System Fundamentals is for you. But I encourage you, don't take my word for it. Here are some testimonials from our students. So William from a major BAS manufacturer says, before BAS Fundamentals, I had no idea of how things came together. Not only do I have an understanding now, but I've learned there was much more to it than I previously thought, and I'm looking forward to learning more and putting this knowledge to good use. And Brendan, who is also a tech from a major BAS manufacturer, says that this is an excellent course layout and segmentation, found the instructor to be very knowledgeable, and he explains subject matter very well, often boiling things down to simple, relatable concepts. So you can enroll now in this course by going to Building Automation Monthly buildingautomationmonthly.com/156, and then scrolling down and clicking on the BAS Fundamentals logo. All right, so with that, before we dive into inputs and outputs, we need to get clear that the average BAS consists of 4 parts. If you've been through any of our introductory courses, you've probably heard of 4-tier architectures. We talk about the 4-tier architecture and we talk about the 3-tier architecture quite often. And that is because they are the underlying foundation of not just building automation, but ultimately of most building systems. If you think about it, a lighting system typically has a server, typically has, like you think of a Lutron system, a quantum gateway, and then that feeds off to some actual ballast controllers. And then you have inputs from light switches and outputs to actual lights. Now, you could take that same 4-tier architecture, the server, supervisory device, field controller, which in that case we include the field bus, and inputs and outputs. And as I mentioned, you can apply that to lighting, you can apply that to access control, to AV. I mean, I've integrated all these different systems. And once you understand this 4-part architecture, and ultimately once you understand kind of inputs, outputs, field controllers, supervisory devices, and servers, your ability to integrate is going to go up. Your ability to understand systems is going to go up. Your ability to advise folks on retrofits is going to go up because you're going to really have a picture of how all this works. So if we think about a BAS, right? The inputs and outputs of a BAS are where the actual work is happening. So that's where all the good stuff happens. So that is primarily where we should focus most of our time. Now, here's the deal. Understanding inputs and outputs, it's a little difficult at times. So let's take a look at a non-BAS example. It's getting to be spring here in Wisconsin at the time of me recording this, which means I'm going to be out in the wilderness with my kids. And so imagine this scenario. You're in a forest, right? And your ears process a sound. This would be known as an input. And they send information to your brain, which is basically your controller. And then your brain decides that the sound was a bear and it makes your legs run, which is an output. So we've seen that kind of input. Hey, we've got a sound coming in. That's our input. Brain needs to make a decision. It decides to go and make your legs run. Well, in some cases, you probably shouldn't run from bears. But anyways, it's an example in a podcast episode, so go with me on it. Now, we could take this example even further. Sound is analog, and therefore the input type was an analog input. There are actually two types of outputs that are being driven by your brain. First, you have a binary output to start your legs moving, and then you have an analog output to control the speed at which they move. This is very common in building automation situations where you actually have a fan that is enabled. And then once that fan is enabled and running, then you have a control signal, typically a 0 to 10 volt DC signal, which corresponds to a 0 to 100% signal. And that actually drives a VSD, which then adjusts the speed of the fan, or a VFD, which adjusts the frequency of a fan. There's different ways of achieving basically the same thing. So you see, who knew running from a bear could actually be used to teach you building automation systems? All right, I promise you there will be no more bear analogies through the rest of this episode. But as I said, BAS devices, often controllers, have both physical and logical points. Now, you'll notice a shift that just happened. I shifted from inputs and outputs to physical and logical points. And this is where a lot of folks who are new to the field get lost. We'll often, being the folks we are and the experience level we have, we'll say, oh, the point, this point, that point. But we often don't take time to explain actually what a point is. I mean, what is a point? You take this word point, and it's tossed around so often, but it's really poorly explained. So quite simply, a point is either a software object or a device that serves a specific purpose. Okay? So let me repeat that one more time. A point is a software object or a device that serves a specific purpose. Now, what is that purpose? Well, let's find out. All right, let's focus on physical points. You're like, what the heck is Phil doing today? I promise you, there's no drugs. It's all just caffeine and working out. Energy through the roof. Actually, I'm just really excited to be behind the mic because I thought this computer was going to be dead for much longer, and now I'm super excited to be back on the mic talking to all of you. I've gotten several messages from you saying, "Where's the podcast?" And I'm excited to be back. So, as I said, we're focusing on physical points. All right, let's do that. So we have two kinds of physical points, and those are inputs and outputs. Now, inputs, there's four major types that we need to focus on, all right? The most common input type is a resistive input. This is where you have resistance going across a wire, and that resistance is either variable resistance in the case of a thermostat, something like that, or it is a actual set resistance in the case of like a digital switch, where you either have an open or closed circuit. So you have kind of resistive inputs that are set, and resistive inputs that are variable. Now, these go into your controller, and then inside your controller software, typically, sometimes you'll actually use just a plug-in tool. You'll select what type of input you have, and then they usually have calibration tables so that the resistance is able to be matched up to an appropriate signal type. Now, we also have analog inputs, and analog inputs are usually voltage and or current, and these sensors can either be directly powered via the controller or they can be externally powered. So this is something we talk about a lot in our BAS Startup and Checkout course, but basically analog inputs are usually used in things like humidity, CO2, CO, etc., pressure, things where there is a linear scale and you want to provide something a little bit more linear and a little bit more accurate than resistance. So we use voltage or current. Now, typically, voltage is used for shorter runs, and it's something that is when you're not worried about electrical interference. Current is used for longer runs, meaning longer length between the controller and the actual sensor object. So you use current in that case, and it is more tolerance. I don't want to say it's completely tolerant, but it's more tolerant of electrical interference. And then our final input type is known as PWM, or pulse width modulation. So basically you get an electrical pulse, and based on the difference between the high and the low, so the pulse is digital, it's on and off, and based on the difference in pulse lengths, hence the pulse width is modified. That's an easy way to remember what pulse width modification means because it's in the freaking name, right? I mean, it's pulse width modulation. So we are modulating the width of the pulse. So the pulse, if you were to look at an oscilloscope, the pulse would be an on, and then it would be an off. Or if you were to look at a multimeter, you would have a digital signal, and then you wouldn't have a digital signal. And so your pulse, the width of the actual pulse is modified, and based on that width, you're able to calculate things like how many kilowatt hours is coming from this electrical meter. So these are all things that get fed to you via pulse width modulation. So pulse width modulation is something we usually see when we are dealing with electrical systems. Now, we also have physical outputs, okay? So physical outputs are commonly broken out into three categories: digital outputs, analog voltage, and analog current. Now, we've already talked about voltage and current, so I'm going to focus in here on digital. But real quick, before we dive into that, analog voltage and analog current, okay? Let me tell you why we use these. Typically, we have a VSD or we have a damper, something that is proportionally controlled. And don't worry, when we move to the logical section of this episode, we'll talk about sequence control, we'll talk about two-state control, and we'll talk about proportional control. We might even talk about incremental control as well. Who knows? It depends on how squirrely I'm feeling and how much time we've got left in the episode. I'm thinking we're going to hit the 30-minute mark on this one, but we may be a little under, we may be a little over. All right, so before I dive into digital, let me take a sip of water. Alrighty, so digital. Digital is either known as a hot or a wet or a dry output. So in some cases, what we will have, and this is going to be much easier to explain on the video than it is in audio. I've been racking my brain on how do I describe, and I actually just misspoke. I didn't mean to say hot and wet. I was thinking about inputs for some reason. I meant to say externally sourced and internally sourced voltage. That's what I meant to say for our digital, sometimes also known as binary outputs. Now, I purposely don't use the term binary outputs because that is more of a logical concept. That's more of a two-state concept. We are primarily focused on digital outputs. So, all right, let's dive in. So our digital voltage, whatever you want to call it, output, what is happening typically is we either have 24 volts coming out of two contacts and they are going to a coil on a relay. They are energizing that coil, which is then causing the contacts on that relay to close state, and then voltage is sourcing through those contacts. That is a common way of doing things where we take our own 24 volts, we drive a relay coil, and then we use contacts on that coil to pass through the actual source voltage for whatever device we're trying to power. That is my preferred way of using outputs simply because we are physically segmenting ourselves from that source or that load voltage. So that load voltage that is powering that transformer. It's getting power from the transformer. No, that is powering the actuator. We actually do not have that load passing through our contacts on our controller. Now, externally sourced voltage, we are actually passing through the voltage through a set of contacts on our actual controller. So on our controller, we actually have a coil inside it that is getting energized, and that is causing the contacts to change state, and then that load voltage can pass through those contacts. It'll be really important when you're working with these kind of outputs that you focus in on the amperage rating, actually in most cases the milliamp rating of those outputs, sometimes amperage rating of the outputs, just depends on the controller. But remember, we are not passing crazy amps through our controllers. That is the quickest way to let the smoke out of the controller. It's also why I really don't recommend passing voltage through our controllers and using our controllers as relays, because those are several $100 relays. And when they fail, when there's a spike or a load issue, that controller is going to cook, and that's just bad. So I really recommend using a $5 iDeck single pole double throw, or maybe a Rib U1C single pole double throw. Rib U1Cs are kind of my favorite things out there. Kudos to Functional Device for making a really awesome product. And I would recommend in that case, we focus on using those primarily. All right, so pretty clear on output types, right? We have our voltage outputs. I think I've used like 3 different names for what to call them at this point in the episode, so forgive me for that. And we've got our analog, which is our DC voltage, not our AC voltage. So we've got our DC voltage, and we've got our current. So voltage and current, all right? So voltage and current are going to be our other output types. And as I mentioned, they are primarily focused on driving variable proportional devices like VSDs, like dampers, etc. Now I want to shift gears here, and I want to spend the remainder of the amount of time you and I have together. Once again, thank you all so much for taking time and engaging with me every week. You all are freaking awesome, and I really appreciate the feedback I'm getting on the podcast lately. Thank you so much. So let's go through this concept of logical points. Man, this throws a lot of folks for a loop. I get folks who come into our startup and checkout course not having gone through our Bas Fundamentals course. And at first they were really struggling with logical points, to the point where we started adding a little primer on what logical points were. And I've heard about this as well for a lot of folks who go through the Niagara training or go through my manufacturer's controller training. I hear that they tend to struggle if they don't have a BAS background on this concept of logical, because physical inputs and outputs is pretty clear, right? You can feel them, you can touch them, you can see them. But then we have these concepts called logical points. These points do not physically exist. They exist only in software. Now, these logical points consist of inputs, values, and outputs. And I'm going to take one more sip of water because my throat's really dry. All right. So inputs, values, and outputs, right? Now, usually there is a one-to-one relation with a logical input and a physical input, and a logical output and a physical output. Usually they are the same thing. However, I will also tell you that there are manufacturers out there, especially with backnet devices, who create analog inputs and binary outputs and binary inputs and analog outputs that have no tie to an actual physical point. That's a big no-no. That's breaking kind of the standard for backnet, but hey, that's what some people do. So do not always equate a software input with an actual physical point. So that's my point there. Now, inputs. Inputs typically cannot be commanded. Inputs, logical inputs, typically are for status only. And there are three main types of logical points that we'll see both across inputs, values, and outputs. And those are analog, binary, and multi-state. Now, we haven't gotten into all the different types of analog, and we will, but we're not going to go there just now. So for those of you who are like, but what about integers? What about numerics? What about floats? We'll talk about that in just a second. I'm going to really freak some people out because we're going to go into that, and folks are going to be like, what the heck is Phil talking about? But before we do that, let's focus on the inputs. So we have analog, binary, multi-state. Analog are variable. Binary are two states, on, off, true, false. Normal, alarm. Binary. Multi-state is, guess what? Multiple states. For example, occupancy, occupied, unoccupied, standby, etc. So pretty straightforward, right? Now you carry that entire concept of analog, binary, multi-state across values and outputs, and they are consistent. You're going to have two states with binary values. You're going to have two states with binary outputs. The only difference with values is that values and outputs is that values and outputs are commandable. Inputs are typically not commandable. Logical inputs, that is. Values and outputs, logical values, logical outputs are typically commandable points. So it's real important that we realize that. Now let's loop back to this concept of analog point types. Okay? This is going to be what we close out with here. So analog point types, all right? Analog point types come in a couple different formats. I'm trying to think of the best word to use here. I'm going to use the word formats. And typically what we have are kind of two formats. We have decimal precision and whole numbers. So when it comes to analog, you'll hear of a term often used as numerics or floats or integers. Now, numerics are another way of saying analog. It's an analog point. Now, of that type, there are integers, which are whole numbers, and floats, or doubles or decimals, which have decimal precision, meaning you can put a point after the number, so 100.01, and you get decimal precision. The only reason this is important for you to know is if you start to get into complex like lab control or operating room control, where you want to have decimal precision of the damper, and you're passing through a bunch of damper positions to do a really tight calculation of reset of discharge air pressure or something, then what you want to do is you want to have decimal precision. You don't want to use whole numbers. You don't want to round that up. So that is why that's important for you to understand. Now, you may also hear of objects called Booleans. All right. Booleans is just another way of saying binary. Booleans are true, false. Booleans are on, off. They are two-state objects. And then finally, you might hear of something called an enumeration. Maybe you'll hear it called an enumeration set or an enum. Enumerations are just a fancy way of saying multi-state. So a multi-state is basically an array. So going back to the computer programming world, you have memory, and within memory you have bits and bytes, and bits have ones and zeros, right? And ones and zeros are on and off, and you set the bits. Well, excuse me. A multi-state is typically a byte or a series of bytes in memory. So you've got these ones and zeros, and when you set a specific 1 or 0, that signifies a specific number in that multi-state value. Now that's all gibberish, right? I mean, it's gibberish just listening to it. Me telling you you've got a 16-bit multi-state object and you set bit 12 means absolutely jack squat to you, unless you know that that 16-bit set is a priority array, or that it is a series of zones, because you set a custom enumeration. Now, an enumeration is where you give context to an array. So you've went from this bit array of 16 bits that can be set ones and zeros. Like I said, this is so much easier to explain on video. So I really encourage you watch the video. But you've taken this 16-bit array, right? And you've added context to it by saying, oh, guess what? Bit number 2 means room 101 or means cooling, and bit 3 means heating, and bit 4 means mechanical cooling. So that way, as these different bits are set on, you now have context. That is a multi-state value. That is an enumerated value. So, wow, that went deep down the dark rabbit hole of technical real fast. We went from, hey, these are inputs and outputs, to talking about bit arrays and enumeration sets and custom enumerations and all that jazz. So, as you can see, you could go pretty far down this deep, dark rabbit hole. But I'm telling you, if you understand just the input and output types, and you understand logical points and inputs, values, and outputs, you will surprisingly be pretty far ahead of the curve. There's actually a fair amount of experienced BAS folks, which if you ask them to explain how a multi-state object actually works, what is the concept of a bit array? What is the concept of a custom enumeration? Why do we care about enumerated sets? If you ask them to explain that, there are actually some folks out there who are experienced who would not be able to explain that, but now you can, my friends. So with that being said, this was episode 156. I encourage you to go to buildingautomationmonthly.com/156. I encourage you to check out our Bas Fundamentals course. It is like this, but it is much deeper and much clearer because it's all video, and it is a focused turnkey course. Really encourage you to enroll in that and really take your BAS knowledge to the next level. Next week, my friends, we will be diving through controllers. We will talk through application-specific controllers. We will talk through free programmables. We will talk about DDC. We will talk about what DDC actually is. We'll talk about controllers and how they work and why you should care about them. We'll talk about field trunks. It will be a lot of fun. If you have any questions about this episode, I encourage you to go once again to buildingautomationmonthly.com/156 and ask your questions there. Until then, thanks so much for being here. Sorry about this being a little late. I can't wait to talk to you all in next week's episode. Till then, take care. Thanks for being here. Hope you all have a great week.